All right. Okay, so organic and inorganic. Yeah, thank you. Thank you. Yeah, thank you. Good evening. 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 Good evening, everyone. Good evening. So this is just this revision, general revision, this general revision. Okay, this general revision. Just be talking about organic chemistry, inorganic chemistry in like less than 1 hour or thereabout. Okay, I don't know if they have joined. All right, can we start? Definitely. Yeah, thank you. Thank you. So basically, I don't know if you can start. Okay, so without wasting much of time, it's basically revision. Okay, I have less few times to spend here, but just basically revision class on how you can ace your exams. Okay, my name is Deechemistrytutor, right? And it's good to be here to teach you guys some of the basis of organic chemistry. So we'll run through it as the case may be. So now, some of the questions that they will ask you, some of the things that you have to know, because this is a crash class, okay? It's organic chemistry revision, basically. So then, if at all we move to some inorganic chemistry revision, then we'll see how we can go, how far we can go, okay? I don't know. Are we good to go? All right, so now, yes, sir, good. Okay, let's get to work. Now, organic chemistry basically is the study of, of compound, of carbon, and like study of compound of carbon and, okay, study of chemistry. Sorry, let me use chemistry. What am I writing? Let me just start again. Organic chemistry, right, is the study of carbon and its compounds, with the exception of CO2 and CO, then triazocarbonate. What do I mean by triazocarbonate? Is CO3 2 minus. Okay, there's not much talk. You just want to get straight to the work. So that means these guys here, they are inorganic. So any compound of carbon and its compounds, with the exception of CO2, CO, and triazocarbonate, we say it is an organic compound. Okay. So what do I mean? Now, the main thing is that carbon is a very special guy because it tends to bond with itself like this. Carbon can bond with hydrogen. Carbon can bond with other elements like oxygen. That is so unique. It can even form a branch chain. It can form a branch chain. Look at it. Carbon is so unique. It's so unique. This is carbon. So carbon is so unique. So now, because carbon can bond with itself and bond with other elements, this ability of carbon to bond with itself and other elements like this, and form branch chain is what we call what? It's called catenation. Catenation. Okay, so note this. They can ask you this. So catenation is the ability of carbon to bond with itself, carbon to bond with other elements like this, and like that. So any compound of carbon, with the exception of CO2, CO, triazocarbonate, it's called an organic compound or organic chemistry. Okay, so now, but the point is, before now, what actually happened is that the word organic means living. The word organic means living. Okay, so when they hear organic chemistry, the thing that came to their head was that this is compound that must come from what? Living organism. That is, that must come from plants and animal. But that is a lie. Until 1927, there was a man, Frederick Wohler. In 1927, Frederick Wohler, this is a JAMB question. It can synthesized the first organic compound. So you imagine that has already, jeopardized that definition that, oh, it is a compound that must be from living organism, either plant or animal, because this guy in 1927 discovered the first organic compound in the laboratory. So that's another JAMB question. What was the first organic compound to be synthesized in the laboratory? That's urea. Urea, yes. Urea was the first organic compound to be synthesized in the laboratory. The first, okay. And that was, he used what we call ammonium cyanate, okay. He used ammonium cyanate. He heat up ammonium cyanate. Then he realized that there's a formation of what? NH2 bracket 2CO. Do you understand? NH2 bracket 2CO. So this is the compound we call urea. Okay. If you want to draw the structure like this, you see that this will be C double bond O, NH2, NH2. Okay. So this is the compound we call urea, and it's the first organic compound. In fact, this was what led to the redefinition, right? Redefinition of an organic compound to be compound of carbon and its, it's a study of carbon and its compound, with the exception of CO, CO2, and triazocarbonate, because this guy was in the laboratory. So using what we call ammonium cyanate. Ammonium cyanate, okay. So that is what happened. This is the first. This is another JAMB question. The first sorry, you are going so. This is a revision class, okay. Just follow through what we are doing, okay. The first organic compound to be synthesized in the laboratory is urea, okay, and is by using ammonium cyanate. Okay. So just take note of that. No, this is not a class, or this is a general class. Is not the chemistry tutor class, please. James Ojia, but I don't know what you're talking about, okay. So now, just like I said, ammonium cyanate, okay, to give this, then this is what happened. Now let me give you a brush through of the whole concept itself. Okay, now let's say we have organic chemistry, okay. Then this guy can be divided into two. It will be hydrocarbon. Yes, good. Hydrocarbon, and what we call what? Non-hydrocarbon. Okay. Now, when we say hydrocarbon, what do we mean by hydrocarbon? We are talking about what? It can be aliphatic or aromatic. Okay. Now, under the aliphatic, right? Aliphatic. Now, that's where you see something like, the alkane, alkyne. This is not the class, yo. This is not in class. This is not the class. This is a general class. That one start by 7, Juliet. So this is alkane, alkene, and alkyne. Now aromatic is what? Is benzene. Okay, is benzene. Aromatic is benzene. So they call them amines. They call them amines. that this here can't hear you. What's happening? Can you guys hear me? No. Sir, please quit. Wow. What's happening? Can you guys hear me? Yes, okay, good. I hope you can hear me now. You guys can hear me. Can you guys hear me? Yes, now. Okay, better now. Good. Thank you. Oh, good. Thank you. It is now stable. Good. So the alkenes and alkynes. Someone said, is benzene not noted as alkene? Yet benzene is unsaturated. It's not alkene. No. Benzene is different from alkene. What benzene belongs to is called the arenes, not alkenes. Yes, benzene loves to be, we'll get there actually. Benzene loves to be, to maintain its ring. You understand? It just loves to undergo substitution reaction to maintain that ring, that aromaticity ring, okay? So benzene is not alkene. Alkene is different from arenes. So these two guys, we call them unsaturated, okay, hydrocarbons. Now, why are these guys under hydrocarbon? The word hydrocarbon means it contains carbon and hydrogen only. That's why if I ask you, is C2H5OH an hydrocarbon? The answer is no. C2H5OH. Oh my, can you guys hear me now? Can you guys hear me? What's happening? Can you guys hear me? Some people can hear me, some people cannot hear me. Okay, I think it's some networks. It is their network, Jerry. Now, O is here, right? Now, because oxygen is here, it's not just containing hydrogen and carbon only. That means it is not an hydrocarbon, okay? But it is an organic compound. It is an organic compound. That's what you have to know. So, that means all organic compounds are hydrocarbon, but all hydrocarbons are organic compound, but not all organic compounds are hydrocarbon. Look at this one. This one is an ethanol. This one is an ethanol because it has OH group. But this O here makes this not an hydrocarbon. This makes this an hydrocarbon, okay? So you can see, just take note of this. So these are unsaturated hydrocarbon. Why this alkane saturated? Why is it saturated? Because it has all single bond field. All single bond field, okay? All single bond field. So that's why it is saturated. That's why it is saturated. Okay? Now this one is the king of the bonds. Alkyne is the king of triple bond. Wow. Why is it breaking? I can't hear you. It is breaking. What's happening? Wow. What's happening now? This is okay here. Oh. Your network. Wow. What's happening? Probably the network. Wow. Can you guys hear me now? Can you guys hear me? It is okay now. It is still breaking. It is okay. Okay, thank you. All right, let's continue. So now you can see that it is good. Now this is saturated. These guys are unsaturated. Okay, now these ones, this is where all the other thing belongs. All the alkanol, all the alkanol, all the alkanol. We will do revision on this one. All the alkanoic acid, all the alkanoates, all the amide, all the amine, and all the carbohydrates. Carbohydrate, a lot of them belongs here. Now you can see that if you look at these guys, they are not just they don't just comprise hydrogen and carbon only. They comprise of other elements like nitrogen, like oxygen. You understand? So these guys are under the non-hydrocarbons. Why these ones are under the, the hydrocarbons? Now let's pick this one. Let's pick this one and dwell on it because it is so important. Okay. Now look at what happened here. Look at what happened. So the alkanes, just like we said, they have a general formula of CnH2n plus 2. This is a JAMB question. This is a JAMB question. You have to take note of this. The alkane has a general formula of CnH2n plus 2. And it has what we call what? Single bonds. You must know that. Single bonds. This is a revision class. So single bonds. Another thing that you must know about alkane is that they have what we call sp3 hybridized. sp3 hybridized. You must take note of this. They are sp3 hybridized. That means their bond angle is what? 109.5 degree. You have to take note of this, okay? They are sp3 hybridized. This is alkane. They are sp3. And another name for them is paraffin. Paraffin. Now, the word paraffin actually comes from the word para plus affinity. Para plus affinity, which means they have para. When you para, it means you para for someone. Leave me, Joe. So it means little. You don't like the person. So little plus what? Affinity. So the word paraffin means little affinity. They don't like to react. You understand? So they have little affinity. That's why another name for alkane is paraffin. All right. Take note of that. It's very, very important. Now, another thing that you have to take note about alkane is that they have homologous series, Abi, and this homologous series must have a name that must end with their family name. Just for instance, let me use John for instance. Or yes, John. If John belongs to the Ojo family, you will see that John name will be John Ojo, right? John Ojo. If John has a brother that bears Tokpe, it will be Tokpe Ojo. Now, what does this mean? It means that their family name is always the suffix, right? So that is the way these guys are. Since we said their general formula is CnH2n plus 2. So if the first member, the firstborn is n equals to 1, and you put it here to be C1H2 into 1 plus 2, right? So if this is so, we can say this is what? CH2 times 1, 2 plus 2, that's 4. Yes, I will talk about that. So that means because this C is 1, his name will start with Met. So this is the John Met. Now, because this guy belongs to the alkane family, so it will be what? Methane. A. So if n equals to 2, that will be what? Based on this general formula, C2H2 into 2 plus 2. So now, because this guy is, the carbon is 2, C2, 2 times 2, 4, 4 plus 2, 6. So it will be what? 8, because it is 2. Because it is 2, it will be 8. Now, because it now belongs to the John family, which is A, it will become ethane. So take note of that. Now, so that is that. It has, you should have known up to like 10. So if n equals to 3, you should know that that is what? Propane. You should know that. Okay, I have to tell you a JAMB question. If n equals to 4, that's what? Butane. Note that this is the first member of alkane to undergo isomerism. It's a JAMB question. You know, this is revision, okay? I can't go deep into all these things. There are a lot of deep stuff, but just know that butane is the first member to undergo isomerism. Take note of that. Now, these are JAMB questions that they can ask you, as I've said it. All right, so just the first member is this. Now, there's a gas that is in, okay. There's a gas. No, some of you have gas at home, gas cooker, domestic gas, Abi, domestic gas for domestic use. There's a 2-member of alkane that is used for domestic use. And the way I know it is that 34. How do I know? C3 and C4. So that means propane and butane is the gas in your cooking gas, like that your gas at home. So propane and butane, you understand, that's the gas for your cooking that is you use at home, that you go and buy. So take note of that. It's a JAMB question. So that's that. What can I say again? Well, one thing that you must know, that homologous series of alkane, okay, what do we mean by homologous series? Most of you cram this thing, and it's very easy. For homologous series, they are, you guys, if you have siblings, all of you plus your siblings are homologous series of your family. So that is why we define homologous series as what? Members of what? Of an how about methane? Thought it is main constituent in that. Yes, that's another JAMB question. Methane, another, please. It is also the one in minus too. You should know that it's the main constituent of natural gas. You know, these are JAMB questions. Thank you for that. So they are members of what? Organic compound, right? That means look at all your siblings, you are members of your family, Abby. So that's why you guys are homologous series with what? Similar method of preparation and also what? Same physical property. So this is like a crash, like, you know, there are a lot of things I would have love to talk about. So that means look at it, your siblings and your elders, your junior brother, you are all homologous series. That is why methane, be the first member, is an homologous series. That is why ethane, be the second member, is an homologous series. Propane, be the third member, is an homologous series. Okay, now, but there is a question JAMB we ask you here. If you look methane, since I already told you the general formula, that is CH4. Yes, we'll get there. Then this will be what? C2H6. There will be this C3H8. Now, if you subtract this from this, who can tell me the answer? C2 minus C1 will be C. 6 minus 4 will be H2. Now, let's subtract this from this. C3 from C2 is what? C. H8 minus H6, that's H2, right? That is why they say that this is a question in JAMB, each homologous series differ by dash CH2. This is a JAMB question. Now each homologous series, what I mean by homologous here, I'm talking about each successive. You can see that it is this and this that I subtracted, not this and this. It is this and this I subtracted, not this and this. So it must be successive. So this and butane, so they differ by CH2. This is a JAMB question. Or if they don't put CH2, they can calculate the molecular mass. So C is 12 plus 2 times 1, which is what? Which is 14. So in JAMB, 12 plus 2 is 14. So you might not see CH2, they might put what? 14 gram per mole. This is another JAMB question, okay? This is another JAMB question. Take note of that. So these are another JAMB question. Take note of that. All right. So let's move. Now, focus on what we are doing. Okay. So let's move. As I was saying, okay, we talk about this now. Another thing that you must take note of is that if you want to get preparation, actually, there's a method. We already said that they have similar method of preparation. Okay, for instance, now if you want to prepare COONA, let's say you want to prepare methane plus NaOH. Okay, so we use what we call sodium. Look at this. This is ethanoate. Okay, plus this is caustic soda. Okay, caustic soda. So now, if I want to prepare this guy, it's simple. Look at this CH3. Just bring it here. Look at this hydrogen here plus H. So this guy will give me CH4, Abi. So this is methane. Now go and look at what is left. What is left? N is how many? 2. Na2. C. Then how many oxygen is left? 1, 2, 3. CO3. So this is how to prepare. So if I want to prepare, let's say I want to prepare this is methane. Let's say I want to pair ethane. It's easy. If I want to pair ethane, I'll just say CH3, CH2, COO, Na plus NaOH. Same thing. Just take all this guy, then add H to it. So that will be what? CH3, CH3. So this is ethane. That C2H6, abi? C2H6. Plus what is left? Na. How many Na? Na2. C. Then oxygen 1, 2, 3. CO3. So they have, you can see that they have similar method of preparation. Do you get? They have similar method of preparation. So just take note of this. This is sodium ethanoate with caustic soda to give this. So now let's just like I said, this is this. But there's one thing I want you to note is that there's one that is so peculiar, is using aluminum carbide with what? If you dissolve aluminum carbide, understand, in water, aluminum carbide, if you dissolve it in water. Now this guy, you must take note of this. If you dissolve aluminum carbide, it is specifically for methane. This is what I want you to take note. It is what? It is specifically for what? For methane. It's not for all of them. This method, aluminum carbide, is specifically for what? It's specifically for methane. It's not for all of them. So if you want to prepare methane now, for instance, methane alone, I will just go and use what? Aluminum carbide to prepare methane alone. So it's not generally for all of them. Do you get? So if I just dissolve this guy in water, you just have what we call AlOH bracket 3, then you have what? CH4. So this is for methane alone. Only methane only. You cannot use this one to prepare ethane. You get? So take note of this. What is the reaction? This is the reaction now. Aluminum carbide dissolved in water to give this and methane. So that is that. Okay, another thing that I want to tell you is that okay, cracking and reforming. See, this is a revision class, okay? You cannot do everything like this. That's why I focus on this. Cracking is when you break a long chain hydrocarbon into what? A smaller chain hydrocarbon. Yes, it will be uploaded, it will be recorded, okay? Smaller chain. Why long chain into smaller chain, right? That is cracking. You want to break it into smaller one. But reforming, right? Yes, it will be recorded. Reforming is, yes, long chain, exactly, into this. Reforming is not totally breaking like that. It's changing the form. Is changing the form of a long chain into what? Into a branch chain. Now there's a purpose to increase the octane rating. It is to increase the what? Is to increase the octane rating. So reforming is converting long chain into a branch chain. You understand? To increase, there's a purpose to increase the what? Octane rating. You understand? The performance of the fuel. Okay, you guys should have seen something like that when you want to talk about performance of a fuel. So you see something like, you know, cracking and the likes. Okay, so don't forget. So the purpose of cracking is to what is special about octane normally? Yes, there's something special about octane. Okay, and I will tell you that, you know, when we talk about, I don't know if you guys have seen something like the isomerism of N-octane. Have you guys seen something like that? Isomerism of N-octane. Have you guys seen something like that? You know, if the performance is not good, there will be what we call knocking. You understand? That's what we call knocking of engines because of the octane rating is low. But we want to improve that octane rating. You understand? So it must be better. You understand? So that is why there's something called anti-knocking agent. You understand? That's what, I don't know if you have seen anti-knocking agent. It's octane used to enhance. It's the rating that is used to enhance fuel. Do you get? It's the rating that is used to enhance fuel. So you would have heard something like anti-knocking agent where they say lead 4 tetraethyl. This is another JAMB question. Lead 4 tetraethyl. It is used as anti-knocking agent. This is a JAMB question. Anti-knocking agent, okay? Lead 4 tetraethyl is used as what? Anti-knocking agent. Please take note of this. It is very, very important. Very, very important. Very, very important. So now let's just move a bit because we'll go fast now. I have seen that. You will see it. I'm teaching you and I'm giving you likely questions. This is not the time to understand so much because there's a lot to cover. It's just a revision class. Now, another thing, sir, it is higher than knocking. Does it mean that it is better? If it has higher anti-knocking agent. No, this anti-knocking agent is an additive, is added so that the knocking, like the octane rating, you know, for a fuel that has lower, what is it? I've told you, cracking is just breaking long chain to smaller chain. Reforming is converting a long chain into a branch chain to increase the octane rating. So there's a purpose for reforming. So when anywhere you see, in fact, it's not, it does, in fact, they can even add another thing to reforming, just that to better the fuel. Unlike cracking, you just want to break long chain to smaller chain, like breaking an alkane now, for instance, to alkane, then it can release hydrogen gas. So this one is just cracking. You are just cracking it. But reforming, there's a purpose. You want to increase octane rating. Okay, sir, what is octane rating? Octane rating is the performance of a fuel. I already told you that. Octane rating is the performance of a fuel. Take note of that. Okay, now, see, guys, there's no time. Exam is tomorrow. That's why we have to be fast. Just be writing all the things I'm telling you, okay? Octane rating is the performance of a fuel. And you must know that there's, you know, I don't know if you guys have seen what we call N-octane. Have you guys seen all this? How many of you have seen N-octane? How many of you have seen it? How many of you have seen this? Good. The bond angle of water, please. 104.5 or 105. So N-octane adds an octane rating of 0. You must know this. Why the branch chain? Look at what I will do now. Have you guys seen 2,2 4 trimethyl propane or pentane? Sorry, pentane. How many of you have seen something like this? How many of you have seen 2,2 4 trimethyl pentane? How many of you have seen this? Exactly, good. So this one has an octane rating of 100. You see, so you see that we increase from a long, this is a long chain. That's why this N here means normal heptane. So this is like a long chain. 1, 2, 3, 4, 5, 6, 7. But this one is now branch chain. So this one is better in terms of fuel. So the knocking ability of this one will be reduced, unlike the other one. So it has an octane, or sometimes they call this guy, they call it is an iso-octane. It's an isomer of octane. Why? Because octane has carbon, 8 carbon, abi? 8 carbon. If you check this, this also has 8 carbon. Okay, take note of that. So that is, please take note of this. This is a JAMB question. Let's move on. There's no time. So now you have to, I want to teach you what we call petroleum, and I will teach you some things about petroleum. The word petroleum means crude oil. So petroleum, crude oil. So in your JAMB English, if they say the person is crude, the word crude means unrefined. Unrefined. That's what the word crude means. Unrefined. Okay, that's what the word crude means. Unrefined. So now, if you know this, that it means unrefined, that means this guy has to undergo what we call what? Fractional distillation. Fractional distillation. Okay, I'll be done with alkane after this part, so that we can move to the other part. It's just revision. Okay, now if you undergo fractional distillation, most people don't know the constituents. So you will have seen fractional distillation based on what? Boiling point. Okay, separation techniques. You should have seen something like that based on boiling points. So now, if petroleum, this is what they do here, undergo fractional distillation, the constituent is what? P squared knows this little fine boy. Okay, what do I mean? P squared means 2 p's, abi? Then nose, K, then this is nose, then this is this, then this is little, then this is fine, then this is boy. I want to teach you how to know a lot of things here. This is a JAMB question. They love this. Exactly. So this P means petroleum gas. Petroleum gas. This is the first quantity that will boil out at a temperature lesser than 40 degrees Celsius. You must know this. I will teach you how to know everything. Don't worry. Why this one is what? The next one is what? Is petrol. This one they sell. That liquid that they sell in stations. This is petrol. So this one will boil out at 60 to 100. I will not teach you. Don't worry. This is the only thing you need to know. Yes, I will upload it. So petrol 60 to what? 100, less than 40. What does this nose means? The nose means what? Kerosene, the one you use to cook at home. Now, from here, don't stress yourself. You know, you already know that this is 60 to 100, less than 40. From here, don't stress. 100 to 200. Diesel, this means diesel, which is what? 200 to 300. Then little means lubricating oil. Lubricating oil. So this is 300 to 400. Now this means what? Fuel. This means what? 400 to 500. Why this one means what? Bitumen. Bitumen. I don't know. You should have seen this thing. Or they call it asphalt. This is what they use in what? Or sometimes they call it residue self. How many of you have seen where they construct road before? So this is what they use in road construction. JAMB question. Construction. Okay. This is a JAMB question. That black thing that they pour on the road is the last product of petroleum. So why this one? The temperature is greater than 600 degrees Celsius, the boiling point. So this is how to know them. Yes, road construction, that black stuff. So please never forget this thing. It's important for your JAMB. Okay. What else do you need to know about alkane? Where the major reaction of alkane is substitution reaction. Is a JAMB question. Is substitution reaction. So please take note of this. So now, another name is called olefins. Olefins. Now the word olefin means what? Moderately reactive. That's what it means. Moderately reactive. Okay, you must take note. And we already talked. They are sp2 hybridized. They are sp2 hybridized. They are sp2 hybridized. They have what we call what? Double bonds. Double bond. Like this. Can you guys hear me? Can you guys hear me now? I don't know why it's cracking though. Can you guys hear me? I've already told you alkane is called paraffins. Alkane is called paraffin. Yes, sir. Okay, good. There's no time. Double bond hybridized. They are sp2 hybridized. They are double bond. And you guys should know something about this. If they are like this, that means this is the first member actually. The first member is what? Is ethene. Please note, another name for ethene is what? Ethylene. I don't know why people miss it. Ethyl, ethene, ethylene. E is still the same E-N-E. Okay, ethylene. So that's another name for ethene. So this guy is used in ripening of fruits. That your banana that they used to ripe is ethylene, which is the first member ethene that is used in ripening of food. JAMB question. Biology itself is important. So you can see now this bond here is called pi bond. The one below is called sigma bond. That's just it. So it means this guy has this pi bond and this sigma. All other ones too, they are called sigma bond anyways. But you might not dwell on that. I just want to know that this guy, anything that has double bond, the up one is the pi bond. Do you get? Just take note of that. Yes. So this guy is called pi. This guy is called sigma. That's what you should know. And they love to undergo what we call addition reaction. Addition reaction. And this guy also, they form what we call polymerization. Of course, you should know that there are two types of polymerization: addition polymerization and what? and condensation polymerization. So just take note of that. For the difference between these two guys is that for additional polymerization, there's no loss of substance, but for condensational polymerization, there's loss like substance like ammonia, like water. Okay, there's lost. Okay, just take note of that. What should you know about alkene again? Well, of course, you should know how we prepare alkene, like ethane, the first member. You should know how we prepare them. Okay, and of course, you should know the general formula of alkene. What is polymerization? I think you are interchanging it. The first one is sigma. Why is it? It does not matter. Is what? Let me. Okay, this is the answer. Okay, you want me to go far? Now look at it. If you have, you guys cram all these things, that is where the problem is. If you have a triple bond like this, okay, oh yeah, now if you tell me the first one is sigma, the second one is pi, what will you say to this one? Because this is what? This is an alkyne, Abi. Don't cram these things. There's nothing like fast route to it. This middle one is going to be the sigma. This will be the pi. This will be the pi. That's why alkyne has 2 pi bonds, like ethane, for instance. This is ethane. It has 2 pi bonds so that you don't cram it. So where we have sigma bond is that it is between carbon to carbon. There's nothing like cramming here. So when you now have another bond on top, it will be pi. When you have another bond below, it will be pi. Don't cram. Don't cram. There's nothing like cramming. So there's nothing like one is on top, one is below. Just understand the concept. So where we have the bond itself, sigma is between carbon to carbon. Then another one is that is between carbon to hydrogen. So don't cram these things, okay? You don't need to cram what you just understand. Once you understand, all these things they are work over for you, okay? So that is why. So if I draw a kind now, you can see that the pi is here, pi is here. So between carbon to carbon, that's where you have the sigma bond. Okay, very important. I wanted to say something, and I already told you. Okay, someone is asking polymerization, just like the word polymer. So if you want to form polymer, that means there must be combination of what? Monomers. There must be combination of monomers. Okay, so that is what you have to understand. So there can be polymerization where you have PVC, polyvinyl chloride, polythene bag, that your nylon bag. Polythene is also from ethane. PVC is also a polymer of from ethane and all of that. But I don't want to just take note of that. I don't want to dwell on that so much. All right, because this is a revision class, that you just have to take note of little things. Okay, now you should know something too that is very, very important. Is the Cis the same way we use bromine water to test? Yes. The Cis and trans. Look at this guy. CH3, then H. Then you can have CH3, then H. Now look at this guy. These guys are together like this. So because they are together, we call them sister. So cis, they are cis. The name here, you must start with cis because they are sisters. Now, because these guys are on the opposite side, so we call them trans. So if you want to name this, you must name it like this, 6. But look at them, what is the name of this guy? 1, 2, 3, 4. That means the longest continuous carbon chain is 4. What's the name of this guy? 1, 2, 3, 4. The longest continuous carbon chain is 4. So if I want to name this guy, this would be what? Cis boots. Because this double bond is on carbon 2, it will be boot 2 in. Now, if I want to name this guy, this guy will be what? Trans. Because the double bond is on carbon 2. 1, 2, 3, 4. 1, 2, 3, 4. So it will be trans boots 2 in. Do you get? So we call this, because of their geometric shape, we call it geometric isomerism. Geometric isomerism. This is a class. So it's not that I'm going deep into it. Now, there's a question JAMB used to ask, which one is stronger between cis and trans? The way I know it is that this means sister because they are together. And you know that the bonds between sisters are stronger. So cis is stronger than trans because they are sister. So cis, there are a lot of isomerism. Okay, you guys want to read, so shall see a lot of things. Basically, there are 2 classes of isomerism. There's something called structural isomerism, but I'm not going to dwell on them anyways. I just want you to know. And there's something called what? Stereo isomerism. Okay, isomerism. So there is something called straight chain isomerism under structural. Okay, there's something called straight chain isomerism. There's something called geoisomerism. There's something called functional group isomerism. Okay, so please optical. Okay, I'll talk about that one because there's something called positional isomerism. Okay, there's something called metamerism. There's something called tautomerism. These are things I don't want to dwell on. No, you guys, it's revision, guys. So under this guy, under stereo, there are just two: geometric isomerism and optical isomerism. And that is because of this guy we now talk about what we call what? Chiral carbon. Chiral carbon. Okay, chiral carbon. What the term isomerism is a phenomenon where a compound of the same molecular formula but different structural formula. Okay, same molecular formula but different structural formula. So just take note of this one I said here. It's very, very important. Optical isomerism is the same as molecular but different configurations. Yes, and you guys shall love to. So for instance, look at this. Carbon is bonded to CH3, H, Cl, and F, for instance. So because what is here is different from what is here, is different from what is here, is different from what is here. So we call that carbon, we call it chiral carbon. So chiral carbon is a carbon that is bonded to 4 different atoms. Chiral carbon is a carbon that is bonded to what? 4 different atoms. 4, it must be different, and it must be 4 different atoms. That's why there's a question in JAMB that glucose has how many chiral carbon? Please take note, 4 chiral center. This one I might not have to prove it now because it's a lot. Just take note that glucose has 4 chiral centers. Okay, so that explains that. Look at this carbon, it's bonded to 4 different things. This one is different from this. If I ask you now, CH3, is this guy a chiral carbon? No, it's not a chiral carbon. Why? What is here is the same as what is here. This one is also the same as what is here. So it's not bonded to 4 different atoms. So this one is not a chiral carbon. So if we don't have full knowledge on this, you need to know organic. 5 questions can come out in organic, or 3. So this one is not a chiral carbon. Okay, it's not a chiral carbon. Okay, okay, let's go. Is John here? John, are you here? Can you see? Are you following? Can you see this? I can't really see the comment section. I don't know if it's still possible to even collaborate, right? Okay. So as I've said that, what else should you know? What else should you know? John, okay, thank you. So thank you so much. So let's continue as we've talked about. So alkynes, of course, you should know something that is important. The reaction that is common to all organic compounds, reaction that is common to all organic compound, you must know this one. Compound is combustion reaction. Okay, is combustion reaction. Functional groups, okay, I will talk about that after this. Is combustion reaction, and you must know that if any hydrocarbon CN, let's say CXHY, undergo combustion reaction, you can come back to it later. Okay, CnHY plus oxygen, if it is a 2 condition, if it is a complete combustion reaction, it must give CO2 and water. But if it's number 2, if it is incomplete combustion reaction, it will give CO and water. You must know this one. You must know. But all organic compound will undergo combustion. They can burn in air to give this. If it is complete, if it isn't complete, it will give this. Okay. So now that is that. What reaction does alkene on that? I'll say this now. Addition reaction. You guys are not following like that too. Addition reaction. I said it. So let's go. Let's move on. When this guy is limited now, You guys say when they say incomplete, this oxygen is not enough. That is why it's not able to convert CO to CO2. So because oxygen is not enough, it will just be forming CO and water. But if oxygen is enough, it will form CO2 and H2O. What alkyne? Yes, low oxygen content. So let's go. So we'll go to alkyne now. This is just a revision class, so it's not deep stuff, okay? Please just follow what they can ask in each of them. That's what I'm trying to tell you. Alkyne, another name for alkyne is what? Is acetylene. Acetylene, that's another name for alkyne. And alkyne has what we call sp hybridized, sp hybridized, okay? This is alkyne. This is the first. I'm just at alkyne now. We are starting from beginning now. Why do you guys not the follow up like this? We are starting. We have not reached there. We are at alkyne. This is a crash class for organic. Alkene undergo what reaction? Addition reaction. So sp hybridized, abi, take note. That means the bond angle of alkyne, because it is sp, it will be 180 degrees. You guys used to cram this thing, but it's simple. Look at the way alkyne is. The first member is ethyne. Look at this. It shows that the angle between this guy, because it's a straight line, is 180 degrees. So any sp hybridized, we have a bond angle of 180 degrees. And the shape, because it is sp hybridized, the shape will be what? Linear angle on a straight line, linear. That will be the shape. Okay? I told you now, ethene can be prepared using what? Reaction with ethanol using concentrated H2. Please, there's a JAMB question here. But this concentrated H2O must be in excess. That is very, very important. Dehydration of ethanol using concentrated H2O in excess. Shape of ammonia. Ammonia is trigonal pyramidal. See, there's a JAMB question here, because if ethanol is in excess, it's not going to form ethene. It's going to form ethoxyl ethane. It will form another thing. I don't want to go deep, guys. This is a revision class, okay? Ethanol, if you dehydrate ethanol, I don't want to go deep on these things. It's a revision class, so I can cover everything. Alkane tetrahedra. I don't want to go deep. It's a revision class. That's my fear, unless I'm not, because I have to leave here in like 20 minutes time. So I have another class by 7 o'clock. So using conc H2SO4, it must be in excess. It is important. So then we now form what we call ethene. Now this is when it is in excess, when this guy is in excess. But if this ethanol is in excess, this is what it's going to form. If ethanol is in excess, this is a JAMB question. No, ethanol is in excess, it will form what we call ethoxyl ethane. This is ethoxyl ethane, CCOCC. So this guy, when you have ROR, we call this guy alkoxy. You must have heard it. For those that have like read very well, you must have heard this. Okay, alkoxy. So this is what they call ethoxyl ethane. So please take note of this. When this guy is in excess, and sometimes they use temperature like 98 degrees Celsius here, and they use this one as 120 degrees Celsius. Like, you must know this one. Just take note of that. So that is that. As I was talking about, okay, I was talking about alkyne. So alkyne is very special guy. The first member is what? Ethyne, as I've said. So I will still also, for those that do not understand, look at this guy. So this will be pi, this will be pi, this will be sigma, this will be sigma, this will be sigma. Okay, that is ether. Yes, the old name is ether, but the new name is alkoxyl. That is the old name. Ether is the old name. So now look at this. This is ethyne. Now, how do you prepare ethyne? You must know this one. we're using calcium carbide. When you dissolve calcium carbide in water, you produce ethyne, C2H2 plus CaOH bracket 2. So this is ethyne. All right. When you dissolve calcium carbide, don't forget methane is aluminum carbide. Yes, it will be posted. Shape of alkene. They already said it is a planar now. It's 120 degrees. So it will be planar. The shape will be planar. So this is the first member. Okay. Take note of this. Very, very important. Very, very important. So take note of this reaction. Calcium carbide in water is to form ethyne. Now, but what is the shape of... Hey, how many times I want to say it? Like shape of alkene is planar. I already said it is a planar shape because it is sp is sp2 hybridized. Okay, it's sp2 hybridized. Some people call it trigonal planar. Okay, some people call it trigonal planar, depending on what you like see. But some people call it coplanar. So, but it is sp2. That means the bond angle is 120 degrees. It's sp2. Alkane, the shape of alkane is what? Is tetrahedron. In fact, I don't want to go deep. I would tetrahedron, and the angle is 109 degree 0.5. I already saw all these things though. Okay, the angle is 109, the shape is this, and it is sp3 hybridized. Let me even tell you something. Oh, I don't want to go deep. It's a revision class. I can't be saying a lot of things that are important, like that are not important for you for this time. Let me tell you, CH4 is like this. The actual way we should draw this thing is like this. This is the actual way we should draw it. But because of convenience's sake, that's why we used to draw it like this. This is the actual way. Do you know why? So that it can give us that tetrahedron shape. Don't tell anybody you learned this. They don't know it. Most of them. This is the actual way we should be drawing our compound. So this can give us tetrahedron. But because of convenience's sake, we just used to write this. H, methane. Everybody goes on. But this is not correct. But anyways, we are used to this. But this is the way it should be drawn. So I don't want to go deep on these things, okay? I should go deep. I want to spend 3 hours here. I can't spend 3 hours here. I will not be able to touch other things. So it's not going to be nice not to touch what they will ask you because I want to go deep. Okay, this is not the time to go deep. A day to exam is not the time to go deep. All right, so let's continue. Okay, I've talked about. Now I want to tell you something because sir, alkanes are, yes, that's what I said. Now you guys should follow through, please. Now alkyne can undergo what we call substitution reaction. It should not substitution. Don't forget substitution reaction. Okay, substitution reaction. Okay, now alkyne can undergo substitution reaction, but it is a special alkyne. It's a alkyne that has what we call terminal. See, this one is a question. Terminal hydrogen. Look at it. Look at what will happen. You have something like this. H. Now, what is a terminal hydrogen? That's you guys should focus on what is being taught. Focus, so that we can finish on time. Okay. I have 15 minutes left and I'm still at alkyne. So focus so that we can finish on time. Now this terminal hydrogen is this hydrogen that is bonded to a carbon. I have a class by 7, yeah. That is bonded to a carbon that has a triple bond. Terminal hydrogen is an hydrogen bonded to a carbon that has a triple bond. So it is only this kind of alkyne that can undergo substitution reaction. That means, look at this. This guy cannot undergo substitution. Look at it. This guy can never undergo substitution. I will tell you why. Look at it. There's no. This is hydrogen. You see, this hydrogen is bonded to a carbon, but it's not the carbon that owns this triple bond. So this one will never undergo substitution reaction, right? It will never undergo substitution because it does not have what we call a terminal hydrogen. So it will never undergo what we call what? It will never undergo what reaction can it? It can undergo addition now. It can undergo addition reaction. In fact, it can undergo addition reaction to form ethene. It can undergo addition reaction to form ethane because there's no terminal. There's no hydrogen bonded to a carbon that owns the triple bond. Unlike this one that has hydrogen bonded to a carbon that holds the triple bond. So that's where you would have seen something like this. If you have read very well, though, you would have seen this reaction where you have something like this, triple bond C H H plus silver, where this guy will now replace this guy and form H C double bond C then Hg. So you should have seen those reaction. So this substitution, can you see this guy substituted this guy, can you see, to form this? You see, you are saying so generally. It's not generally. I'll be shouting it's only alkyne that has terminal hydrogen. You're not saying generally. Is that generally they can undergo addition, but it's only alkyne with terminal hydrogen that can undergo substitution. So don't use the word generally. It's not general now. This is an alkyne and it cannot undergo substitution. So why do you use the word generally? You choose your terms well. This one will never undergo substitution. It will undergo addition, but it will never undergo substitution. So don't use the word generally, okay? Good. So I think we are good to go with that. So let's go to, before I go to naming, then let me properly talk about alkanol. Okay, this is a revision class. Okay, what is the shape of benzene? Benzene, we'll get there anyways. Okay, I think I should talk about benzene now, because there's something I want to talk about benzene. Okay, before I even go on, there's a polymerization of ethyne using organonickel catalyst. Ethyne using organonickel catalyst. They call it trimerizes. Now, how do I know? Tri means times 3. So look at it. Ethyne is C2H2. So if ethyne trimerizes, like times 3, it's going to form 3 times 2, 6. 3 times 2, 8, 6. So it's going to form benzene. So this is a JAMB question. The trimerization of ethyne gives what? Benzene. JAMB question. This is a JAMB question, okay? This is a JAMB question. Trimerization of ethyne gives benzene. JAMB question. Okay, because it trimerizes. I don't want you to ask question now. Try 3 times. Does alkene? I don't see the question before. Let me tell you, there's no person I'm going to be teaching you that you will not have met before. This is not 1 year experience. This is over 6 years of teaching experience that I'm using to teach you. So I'm not teaching you what you will not have seen before. Okay. No, it cannot undergo substitution reaction. No, it cannot undergo substitution. That's what I'm trying to tell you, that it's only alkyne that can undergo substitution reaction, and it is common to alkane. Okay. Now, benzene. Just note that benzene in 1865 was discovered by August. Shape of what? August Kekule. Why? Shape of what? Yes, sure. Now it will undergo addition. Okay. Of benzene. Organonickel catalyst. You guys are asking questions that they will not ask you. The boiling point of alkane. Do you know how many alkane that we have? So JAMB will now ask you, what is the boiling point of alkane? Is alkane... You guys are funny. Just like you asking what is the boiling point of a family or a whole family. But you must just know that their boiling point increases down the group. They cannot ask you what is the boiling point of alkane. Alkane is a family of an organic compound. Okay? You guys have not read, oh. Hey, I'm scared, oh God. Because you're asking what is the boiling point of alkane. It shows that you have not read. So you should have told me that the boiling point of alkane increases down the group. You cannot ask me the boiling point of alkane. Yeah, what you don't know, that the boiling point increases down the group. So now, benzene is like this. I should be proving why it is 109 here, Abi, when your exam is tomorrow. Try listen to the right thing. You're asking why. Why should have been something you would have asked before now. Just take note of that and go and pass your exam. That's what you need. You don't need why. A day to exam, you need why. Ziz, you need why a day to exam. What you should see tomorrow and pick answer. Okay. Now, look at this. There's a way to write this. You can just do, when you put a double bond here, you leave this place. You put a double bond here, you leave this place, you put a double bond here. Now, this guy can also be like this. look at what I will do. August Kekule dreamt, actually, he dreamt that there are 6 rats running in a cyclic format because the structure of benzene was a problem. Okay, now what happened is that, look at it, you know, I first put it here, I will leave this place and I'll start from here, leave a space, I'll put the next, leave a space, I'll put the next. So that means benzene has both double bonds and single bond, okay, but it loves to undergo what we call what? Substitution. It loves to undergo alkane substitution because it does not like to be affected. This double bond, it does not like it to be affected. So now look at it, you can see that benzene can be this or this, so they call this what? They call it what? Resonance structure of benzene. Good. CnH2n minus 6. CnH2n minus 6. You understand? So where n is equal to or greater than 6. Do you get? So if S is 6, you will see that this will be what? C6. 2 times 6 is what? H12. 12 minus 6. 6. So this is general formula for benzene. But they don't ask you at your level like that. So this is the general formula for benzene. You guys want me to teach you everything in a day like this, Abi? Okay. I have to leave here by 12. So you know by 7. So know what you are asking. You know. I'm teaching you what they will ask you. They are asking me different questions. Phenol. You should know phenol now. When benzene has the OH, methylbenzene, toluene, xylene. You should know all those things. This is what they will ask. I'm just trying to be brief. Like, you cannot do organic chemistry in 1 hour now. Hey, you guys, let's just do the right thing. Please, don't ask questions that you have not seen before. So, alkanol. Are there not 3 resonance structure? How many God. Okay, now this structure you are seeing is resonance. But benzene, we don't write benzene like this. This is what we now draw for benzene. So benzene prefer this because of what we call aromaticity. So that's why they call it aromatic hydrocarbon. So it loves to maintain this delocalized electron. So we just draw benzene like this. 1865. Those people are asking questions, they've read so much. So I think that those are not the people I'm talking to, because they are just asking some questions that they will not ask them. So they are asking somewhat irrelevant questions. So Cn H2n plus 1 OH. Cn H2n plus 1 OH. This is the general formula. Someone asked the other time alloalkanes. So Cn H2n plus 1, because this allo means halogen, so it will be X, where this X can be Cl, it can be bromine and the likes. So but X must be an halogen. Okay, now please note, if you want to differentiate between unsaturated and saturated, we can use what we call what? Bromine water, where this guy, unsaturated, we have no effect, but saturated will decolorize bromine water colorless. Okay, it will decolorize bromine water. Now you can also use another thing like KMNO4 and K2Cl2O7. I have to talk about that one because you need to know it. So bromine water, unsaturated, will change the color to colorless. Now you must know KMNO4 and K2Cl2O7. Still same, is only unsaturated that can change the color. Saturated will never change the color. Okay, now what happens with KMNO4? KMNO4 normally is purple. So I use the word private chat. So unsaturated will change purple color of KMNO4 to what? C, private chat, colorless. Why K2Cl2? You what? Original gangster, OG. Don't go, form OG. So it will change orange color to what? To green. So that is, you must take note of this one. OG, So you tell them the original gangster, orange to green, purple to colorless. Now this thing is not only for unsaturated. You can use same thing with, if you want to differentiate H2S and SO2. The same thing happens. Two of them will change purple color to colorless, purple color of KMNO4 to colorless, orange color of K2CR207 to green. So, but for H2S and SO2, for H2S, there will be yellow deposit of sulfur for two of them. For here, there will be yellow deposit of sulfur. For here, there will be yellow deposit of sulfur. That is what differentiates between H2S and SO2. So take note of that. Okay. Now, you must know alkanol. What should you know about alkanol? There's something called primary alkanol. There's something called secondary alkanol. And there's something called what? Tertiary alkanol. Now, what is a primary alkanol? Look at it. You just have one alkyl group. You just have one alkyl group like this. So this is a what? A primary alkanol. Now, most of you might be wondering, maybe this one is just 2. In fact, let me tell you, if it's up to 10 itself, it does not matter. So far, these guys are denoted as alkyl group. This is also still primary alkanol. Okay, now look at secondary alkanol. Look at it. Look at the difference. Okay, yeah, let me just draw this. Then we have OH here. Then we have CH3. Then we have H. Now look at, this OH is bonded to this carbon, and this carbon is bonded to an alkyl group, one alkyl group. This is another alkyl group. So there's an R1, there's an R2. So because it's bonded to two different, or it doesn't have to be different, it can be the same. But because it's bonded to two alkyl group, so we call this one secondary alkanol. So you have to understand how to note them. So because this guy C that carries the OH is bonded to two different alkyl group, is called secondary. Now how do you know tertiary? Look at tertiary. Look at tertiary. Look at tertiary. OH, CH3, CH3, then CH3. This is another CH3. So you can see that the carbon that carries the OH, the carbon that carries hydric alkanol, sir. This is not hydric alkanol. I know what you're talking. Monohydric, dihydric, and trihydric alkanol. Okay, that's not what I'm talking about. This is something you said that it will force on alkanol. I will talk about that's oxidation. So this OH is bonded to this carbon, and this carbon is bonded to one R, another, okay, let me say R1, R2, and this is another R3. So when this carbon carrying the OH is bonded to three different alkyl group, we call this one tertiary alkanol. Now what they are asking is that when this guy undergo oxidation, this is where I will end here. Like this is where I will end from this alkanol, because it's a JAMB question. When primary alkanol undergo oxidation, the oxidation when I mean with KMNO4, because it's an oxidizing agent, H+. This guy, first of all, it will first form alkana. That's where we are going next. RCHO. That's their functional group. If it is complete, it will now undergo what we call, it will now form alkanoic acid, which is what? RCOOH. Now, secondary alkanol, if it undergo oxidation, it will form alkanone. Alkanone is RCOR. Okay. Now, this is the only product that secondary will give, but tertiary will form no product. No product. That means in exam, first thing you want to realize that what type of alkanol is it? Is it a primary, secondary, or tertiary? So before you now know, if it is partial oxidation, it will form alkana. If it is complete, it will form alkanoic acid. But secondary will form alkanol. Tertiary will form no product. Okay. Take note of this. It's a JAMB question. Well, for those that want to know monohydric alkanol, it's simple. ROH. This is monohydric. It has only one OH. This, you can have CH. You can have something like this. Okay, I'm coming. CH2OH, then CH2OH. Now, because the OH is 2, we call this dihydric alkanol. Now, we can have CH2OH, CH2OH, then we can have CH2OH. Now, because this number of OH is 3, we call this trihydric alkanol. You should know this also. Alkanol. So that is that, because it depends on the number. This is monohydric. monohydric, okay? Dihydric, trihydric. This, you should have heard about glycerol. Glycerol is a trihydric alkanol. Okay, alkanol. This is a revision, it's a crash class, okay? You guys, you cannot learn everything. So please explain how to name organic compound. Yes, I'm going there. That's where I will end. I understand now. Good guy. So now, alkana. The old name is called what? Aldehyde. Aldehyde. That's the old name. They have a general formula of RCHO. Exam. Alkanone. The old name is called what? Ketones. They have a general formula of RCOR. Now, their old name is ketones, okay? Then the alkanoates. They have a general formula of RCOOR. When I mean R, I'm talking about alkyl group. Okay? RC, and there's a way to name this guy. So we'll now go to naming. Yes, proper 1, 2, 3 triol, not 1, 3 diol. Is glycerol, and the name for glycerol is propan 1, 2, 3 triol. That's the name. You guys, you cannot, it's just a revision class. Okay, note this. Now, amine and amide. Okay, amine, this is this is 1 hour of organic chemistry. This is really big. So RNH2. So this is what they call a primary amine. Now let's say we now have RN, we now have another R, then H. Because the R here is 2, so we call this one a secondary amine. If the R is now 3, like this, we call this what? Tertiary amine. Now don't forget, this is amine, not amide. So if we now talk, these are functional groups I'm explaining you. Primary because only 1 R, secondary because 2 R, tertiary because it's 3 R. You name the alcohol first, then we will get there. Most of you have read, I know. That's what I'm doing. This one is a revision. The amide is RCONH2. You see that there's an introduction of CO. So this is for amide. Because there's CO. These are functional group. Functional group. So now let's go to naming. So I've talked about, okay, here. The last one is carbohydrates. I've not talked about carbohydrate. See, this is the sir, is it only organic chemistry? No, you want to, I only have few hours here. So carbohydrates, you must know that carbohydrates, sir, is esters. Yes, alkanoate are esters. Carbohydrates, okay, you should know that we have monosaccharide, we have disaccharide, then we have polysaccharide. Okay, now the mono are the glucose, the 6 carbon sugars, glucose, galactose and fructose. Okay, you must know this. Then disaccharides are the maltose. You must know something about this. This one is 2 units of glucose. Okay, it's a JAMB question. Then the second one is lactose. Glucose must always be common to all of them. It's glucose plus galactose. Then the last one is sucrose. So sucrose is fructose plus glucose. Okay, so take note of this. Now if you want to form disaccharides, these guys will just undergo condensation reaction. These 2 guys, like if we have monosaccharide plus monosaccharide to give what? Disaccharide. So the forward reaction is called condensation. So if you want condensation reaction, if you want to convert disaccharide back to monosaccharide, you undergo hydrolysis. This is a JAMB question. So forward reaction is condensation, backward reaction is hydrolysis. Okay, what about features in JAMB? Okay, features and outward projections. They will not ask you, hey, who is this person? They will not ask you. Features, projection, and it looks like a fish. When you draw it, skeleton of a fish. And outward, that's cyclic. They will not ask you in JAMB. It's positive that they can ask you. It's trying to talk about when we draw glucose. You guys, I'm using, it's a revision class. You guys should not be disturbing other people. They will not ask you. Features is, oh, God. I don't know if you guys still remember all those cyclic. If you want to draw something like this, if you draw glucose like this. This is outward. Fissures is when you just use a skeleton, okay, because it looks like a fish. That's why they call it fissures projection. So, but my past question said forward reaction is polymerization. Forward reaction of monosaccharide to form disaccharide is polymerization. This one is not the one that you talk about. It's when monomers, oh, hey, you guys, monomers combine to form a polymer. You guys, see, these questions are not hard. It's like, so let's focus on revision. Exactly. So when monomers combine, this one, and you have N, this one is polymerization. Now, if you see condensation and you see polymerization, you choose condensation for this one. Oh. Polymerization is when you have, you guys shall want me to be saying a lot of things. C6H5O. C6H12. No, not C6H10O5 into N to now form starch. So in this case now, we say this was a polymerization. Okay, do you get? Because this is repeating units of glucose to form this. Do you get? So that is now. Do you know what happens here? They've removed H2O. Yes, they've removed H2O. So monomers is for polymerization. Oh, you thought I wrote monomers here? This is monosaccharides. Oh, monosaccharides, sugars. So, but what am I trying to tell you? There's something I want to tell you here before I go to namings. Then I'm done. There's something I want to tell you here is that the general formula of let's say glucose, for instance, please note, or generally carbohydrates. Most of you don't even know that carbohydrate is actually the name from carbon plus hydrate, which is water. So most of you don't know that hydrate is water. So it is like carbon and H2O. Most of you don't know. So carbohydrate is carbon and water. So it is CxH2O into Y. That means water must be together like it is H2O. So there's a reason. That means it's the general formula for carbohydrate. General formula. So please note, it is sometimes that this Y can be equal to X, but not all the times. I'll give you two examples. Look at glucose. You know, glucose is what? C6H12O6. That means if I do C6H2O, it will be 6. So that 2 times 6 is 12. 1 times 6 is 6. Then in this case, you can see that this is X and is also equals to Y. But look at sucrose, for instance. Sucrose is what? C12H22O11. Now, can you see from here? X will never be equals to Y. Look at it. Let me prove it. It will be C12H2O, Abi, into what? 11. Can you see that X here is not equal to Y? Can you see? So it is, because it is 11 times 2 is 22. 11 times 1 is what? 11. So that is why it is CxH2O into Y. So this is the general formula. Please take note of that. So now, what is the ratio? It is ratio 1 to 2 now. Like this one, oh, sometimes, look at it. That's, you know, so that's why I want to tell you that if it is hydrogen to oxygen, do you get 2 to 1? But here, they don't have the same number. It's not all the times. Okay, it's almost 7 now, guys. So I will just name, please pay attention, name one alkane, name one alkane, name one alkyne. I hope I'll be able to do this. Then name one alkanol. So if you don't pay attention, you've missed it out though, because I don't have time. I'm supposed to be out of this. So name of alkanol, then name one alkanoid. These are alkanoids. These are where they will ask you questions. Yes, I think that's where naming is most of the times. Okay, all of that ones they might not want to test you. So now let's do this. I might name the complex ones so that you'll be able to understand. But you should go and practice, so because there's no time actually. CH3. Oh god. Okay, so I'll just pick one like this. Pay attention. I'll even tell you the rules, so you don't so you don't miss out on everything. So I will first of all write the rules. You're welcome, you're welcome, you're welcome. So I'll first write the rules. Now, what is the rule? The rule is simple. If I want to name this guy, for instance, the number one rule, the rule, so if you want to screenshot, you can screenshot. The number one rule is what? Identify the longest continuous carbon chain. Chemistry is sweet now. Identify the longest. Number two, the second rule is identify the family. Okay. Number three rule is that identify the attachment. Now, some of you call this attachment, you call it substituent. Okay, some of you call this attachment, you call it something, but it's because of basic grammar so that people understand. So that's why I call it attachment. Then number four is give the least possible number considering alphabetical order. If you can know this rule, you can name any compound, any organic compound. So screenshot these rules, because I'll be fast with the naming. I only have 10 minutes to spend. So screenshot this. If you have not screenshotted, well, screenshot this. Okay, now look at what happens. So let's now name this. Let's use this thing to name this guy. Yeah, look at it. Let's name it. It's so easy, but some people don't know the naming. Now, what did I say? Longest. I did not see. Most of you missed a question. Most of you missed some things here. What did I tell you to identify? The longest continuous carbon chain. Look at it. 1, 2, 3, 4, 5. That is long. 1, 2, 3, 4, 5 is also long. 1, 2, 3, 4 is also a continuous chain. 1, 2, 3, 4, 5 is also continuous. 1, 2, 3, 4 is also continuous. But if you look at it very well, the only way that you can pick, or that is important that you pick, since this one 1, 2, 3, 4, 5 is also as long as 1, 2, 3, 4, 5. So that means the longest continuous carbon chain, longest. So look at it. Longest continuous is what? Is 5. Now look at it. Some people I've seen students said the longest chain is 6. Look at what they do. 1, 2, 3, 4, 5, 6. Which kind of smartness is this? They said 1, 2, 3, 4, 5, 6, 7. They said longest, but it must be continuous. That's what it means. 1, 2, 3, 4, 5, and 6 is not continuous. So this is the longest chain. So that is the first rule. Now, because the longest chain is 5, according to our rule, if the carbon is 5, what must start it? Pent. Okay? Now, because it is all single bond, it belongs to the alkane family. It is called what? Pentane. So that is where the family name comes in. So we've identified the pentane. This is the family name. See, this is the same rule that applies to everything. So if you understand this, you are good to go. Now, what is the next thing? I've done this. Family name. The carbon longest chain is that it is pent. The family that it is a pentane. Why? Because it is all single bond. If it is a double bond, you would have taken of pentane. Good. Now, identify the attachment. Attachment means things that are not part of this longest chain. Oh yeah, let's name. I can number 1, 2, 3, 4, 5. Don't forget, I can also number like this. 1, 2, 3, 4, 5. Okay? I can number this way and I can number this way. So numbering this way, these are substituents now because they are not part of the chain. So that means I have CH3, 2 CH3, Abi. Okay, now based on the first numbering system, what do I mean by first numbering system? Based on this one, that means this CH3 belongs to carbon what? Carbon 3, and this CH3 belongs to what? Carbon 4. That's based on picking this one that is up. Now, don't forget, I can also number like this. So that's what I'll call the second numbering system. So based on the second numbering system, CH3, because it's 2, it's on what? 1, 2. That means this guy is on carbon 2. And this guy is on what? Carbon 3. Now, good. Now look at it. I've identified the attachment, Abi. Now look at it. Give the least possible number. Are you guys still with me? Hello? Hello guys, are you guys still with me? Oh, good. So yes sir, good. Now give the least possible number. The least, look at it. If I add this guy together, it will be 7. If I add this guy together, it will be 5. Between 7 and 5, which one is small? Between 7 and 5, which one is small? Between 7 and 5, which one is small? Because the rule say give the least possible number. So between 7 and 5, which one is small? Which one is small? Between 7 and 5, when I add it, 5. So that's why I will pick this guy. That's why I will pick what? This guy. Because give the least possible. So I will now name this guy as what? How will I name it? I will not see, please take note of what I want to name. I will say 2, 3. Now between two numbers, you put comma. Now if you now want to put, because this methyl is 2, you will now put dash. Dimethyl. Now what is the family name? Methylpentane. So this is the name. You can see the way I name it. Between two numbers, you put comma. Between number and alphabet, you put dash. So this is the name of the first guy. So please, that explains the first compound I'm going to name on alkane. So let me name on alkane. Let me give a compound on alkane. So let's say we have something like this. So let's say I have this. I have little time to spend, guys. Sorry, 1, 2, 3. Emete CH3. So just follow. It's easy. It's not hard. Now because say you guys are not well like explained to. So it's not hard. Oh yeah, I'm pick. The rule is still the same. Oh yeah, identify the longest continuous chain. 1, 2, 3, 4, 5. Let me just add another one here. And I add another one so that it will make sense. 1, 2, 3. 1, 2, 3. Okay. Yes, this will make sense. Okay. Now, longest chain. What is the longest chain? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. I can go like this. 1, 2, 3, 4, 5, 6. It's not as long. So the longest continuous chain is this. Please, it doesn't have to be like this. So it can go like this. Oh, guys, it can go like this. Okay. So the longest continuous chain is 1, 2, 3, 4, 5, 6, 7. That means carbon is 7. So it will be what? It will be ept. Now, please take note of something. I can number like this. 1, 2, 3, 4, 5, 6, 7. I can also number like this. 1, 2, 3, 4, 5, 6, 7. Now, take note of something. If I number like this 1 is for this. This 2 is for this. This 3 is for this. This 4 is for this. This 5 is for this. This 6 is for this. This 7 is for this. If I go like this 1 is for this. This 2 is for this. This 3 is for this. This 4 is for this. This 5 is for this. This 6 is for this. This 7 is for this. Okay. Now, take note. You see now, some people don't bang them already. 3-methylpentane. Okay. You have banged it already. You have banged it. Now, you see another banking. I've seen another banking. So just pay attention first. So now, because this one is for this double bond, this bond, this 2 is for this bond, this 3 is for this double bond. That's why this one will be what? Ept 3 in. Now, that is when I'm using this up number. Now, if I'm using this down number, this 1 is for this 2 is for this 3 is for this 4 is for this. That means based on the down number, this will be what? Ept 4 in. Now, the rule states to give the least possible number. You see, most of you have banged it. This 1 is for this 2 is for this 3 is for this 4 is for this. So between 3 and 4, which one will I pick? I will prefer to pick Ep3 in because it's the least possible number. This one will be wrong. So anyway, you see Ep4 in is wrong. So leave that. Now, because I already picked based on 1, 2, 3, 4, 5, 6. That means this guy is the substituent. Abi, identify the substituent. That means I'm going to pick what? So 5. The CH3 is on carbon what? It's on carbon 5. So that's why this is 5-methyl ept 3 in. Very easy. Easy thing. Good. Crispy get it. 5-methyl ept 3 in. So that is the only compound I'm going to name on that. Of course, I've named other things. I've named this guy. I've named the cis and trans. I've named the cis and trans for you guys. You guys should have, like, it's on the first video, the first part. So that is that. So let's go to another one. Let me name propine. You guys should, at least what I've built now should help you stay up very well. Should help you. So this is the last, this is an alkyne. Why? It has triple bond. So this is easy. Now I can number like this 1, 2, 3, 4. I can also number like this 1, 2, 3, 4. So this guy has 2 names. It's not, but one is correct. It's not the 2. Now, based on this numbering, 1, 2, 3, this triple bond, this 1 is for this, this 2 is for this, this 3 is for this, this 4 is for this 1 is for this 2 is for this 3 is for this 4 is the one in front of it. So based on this first number, you see that this will be what? Because the number is 4, it will be boot. So it will be boot 3 in, 3 yan, sorry, 3 yan. Now, based on this, like, it will be 1, this is for this, this is for this, this is for this, this is for this. So it will be what? Boot 1 yan. Now, there are 2 names, but this one is wrong. This is correct. Okay. All right. What? Sorry. So this is correct, okay? What are you trying to say, John? Are you saying anything? So this is correct. This is wrong. And you see the 2 options in the question. It's not about closest carbon, no. It's that give, sir. Yes. Should I just want to learn to know what this name means. Sorry. So the another name is alkanol. Alkanol, okay? Alkanol. Yes, you're welcome. Alkanol. Let's say we have something like this. This one is easy, sir. So let's say I have OH here. And I have H, CH. You get? So this is easy too. Why not 2, sir? Oh, sorry, John. Why not 2? I told you now. This 1 is for this bond. This 2 is for this bond. This 3 is for this bond. This 4 is for this bond. This 1 is for this 1 is for this bond. This 2 is for this bond. This 3 is for this bond. This 4 is for this bond. So it's not carbon, because this is carbon 2. You now go and say this is put 2 in. Yan. It's wrong. Go. You are welcome. So now look at this. I can number 1, 2, 3, 4. If you have not followed me, you can follow. Hit the follow button, okay? Or subscription button. So now look at this. Or I can also go like this. 1, 2, 3, 4. I can also go like 1, 2, 3, 4. Now because the longest carbon is boot. So but now it can be butan based on this numbering. This all is on carbon 2. So it can be butan 2 all. Now based on this other numbering, 1, 2, 3. This carbon is on, this OH is on carbon 3. It can also be butan 3 all. But which one will I pick? Pick the least possible number. Least. 2 is lower. 2 is correct. Okay. Butan 2 or not butan 3 or this will be wrong. And it will be in the option. Oh. So let me now name alkanoate. That's the last, because there's a rule about that one. Alkanoate, that was where I will stop. Alkanoate has a general formula of CnH2, RCOOR. Okay, alkanoate or ester, they call them ester, is a reaction between an alkanoic acid like COOH and alkanol like CH3, CH2OH to now form alkanoate or ester. Okay, alkanoate or what, or ester. They have sweet smell. In your oil, vegetable oil, we have esters, so they have sweet smell. Sweet, pleasant smell. Nice, you sabi. Why no butanol? What are you saying? What is butanol? It cannot be. It cannot be butanol now. It's 2 or it must. You must replace the functional group. You must talk about the placement of the functional group. Thank you. Follow if you have not, subscribed if you have not. Now look at this. There's a rule that you must know. Is that if you want to write this guy, okay, look at it. It must give out water. That's the first thing. Then, oh my God. My power bank, I think this stuff chop light too, and I have a class to hold now. I think the power bank is dead. Oh my God, sorry guys. Oh my God. Okay, sorry. Oh shit. It's not NEPA, it's my LED light. Oh. So well, anyway, this is the last part. Okay, now there must be water. Then how do I get the water? This is the water that I formed. So that means I'm left with this guy and this guy. So when I write it out, it will be CH3. God. Yay. Guys, I'm coming. These are the things we face. Guys. Hey. So guys, now CH3, you see what I'm doing for you guys. So you guys should subscribe if you have not. Then this guy will come here and form CH2, CH3. Now don't forget that this is what? 2 carbon. So this is ethanol. This is also 2 carbon. So this is ethanoic acid. Okay. So now, but to name this guy, you must always call the ethanol part first. So this ethanol part, you call it first. It will now be ethyl. Then this ethanoate part, this alkanoic acid, you call it last. It will now be, because it is eth too, it will be ethyl ethanoate. Okay, guys, this is where I will drop my pen. Okay, so I hope you can see this. My LED light is off, my ring light is off. And guys, I've been able to do organic chemistry in almost like less than an hour. I'm going to upload the video. Okay, you can also still watch it. This organic chemistry revision. And John, I don't think John, if John is still here, is John still here? So I hope you learn 1 or 2 things, and I wish you all the best. So you guys, you can name this stuff. If I give it like this: CH3, CH2, COO, then CH3. Can you guys name this? Can you guys name this? How do you name this? This is the, it shows that this is the alkanol part. So this is methyl. Then because so because this is what? Methyl. Then 1, 2, 3. Because it has 3 carbon. So it's with methyl propanoate. Okay. Good guy. This is Bella. So guys, you see I'm on in touch to do this. Okay. Thank you guys. I need to go now. Subscribe if you have not subscribed to this channel. No, not methyl metanoate. The number of carbon is 1, 2, 3. Propanoate, 3 carbon. John is not here. John has gone. You see, we see what we faced here in this part of the world. There's no light. Miracle Brain, you have my number. You can send a message to me, okay? If you want to know about my class, you can send a message to me. So, guys, testimony, say bye. I don't know who is testimony. John is not here anyway. So, guys, I hope you guys learn 1 or 2 things. Subscribe to my channel if you have not. And John, thank you so much. John is the, is the major person. He said we should do this for everybody to learn, and we're doing it. So thank you so much. And methyl propanoate, yes. So you can learn a lot. Call the number. Well, this is my number: 07087 24 71 75. This is my number, okay? 71 75, okay? 87 24 71 75. This is my number. You can screenshot it. So guys, thank you so much, sir. You're welcome. Who is John? John is not here. Yeah. He said we should organize something big for sir. Biology tomorrow, sir. So guys, see you guys. Bye for now. Have a great time. Dr. Deechemistrytutor here. So I'm also on TikTok. You can follow me on TikTok, and subscribe here on my YouTube channel. All right. So I'll also upload the video. Okay. So you get to see it. Bye for now.